Hey everyone, and welcome back to Ideanthro. Now today we're continuing our little mini-series talking about, just at a high level, how bioretention systems remove different pollutants. So we've talked about sediment and nitrogen so far, and today we're talking phosphorus. So phosphorus is a nutrient, and it's of concern if it gets down into like large still water bodies like bays or lakes or this sort of thing. It provides a food source for like algae and this sort of stuff that grow in the lakes and can lead to them. It can be a contributing factor to them turning really quite festy and nasty and places you don't want to be to. So it's important that we try and limit how much of it gets into our waterways and water bodies. So we're going to have this chat about how bioretention systems remove phosphorus from stormwater. But to do that, you need to understand that phosphorus in stormwater is available in two different forms. So the first form is it's available in what's called particulate form. And all that means is that the little phosphorus, the little bit of phosphorus coming in is attached to sediment in the water. So it's particulate. The sediment is a particle, so the phosphorus which is attached to it is said to be particulate. The second form that it comes in is soluble form. So that literally just means that it's dissolved in the water. It's not attached to another particle or anything. It's just free in its own form. And these two different forms of phosphorus have got two different removal pathways. So let's talk about each of them. The dissolved form, the particulate form. Particulate form is where we're going to go first. The particulate form is really, really simple. So we talked in the sediment video about how bioretention systems, they have the plants, they have the filter media here, and they have the pipes at the bottom. So the water comes in, filters through the filter media, gets collected in the pipes at the bottom. And we talked about how the sediment simply gets trapped on the surface. The sediment particles physically run into the particles in the filter media and they get left behind as the clean water flows past. And so the same thing's happening here with particulate phosphorus. The particle, the phosphorus is attached to the sediment particles. So when the sediment particle stops, that phosphorus stops as well. Right? So that removal pathway is really quite simple. Now the other type of phosphorus, of course, is the dissolved phosphorus. And this is a little bit more complex, and this actually changes over time. So in the case of the particulate phosphorus, it comes in, it's dissolved, it's just happily floating around in the stormwater, and it comes in and it filters down through the filter media again. And this dissolved phosphorus might just happen to come into contact with a particle in the filter media and it becomes stuck to it. So the same way that the particulate phosphorus was already stuck to a particle of sediment before it got to the bioretention system, the dissolved stuff, when it goes through the filter media, can become stuck to a particle of sediment and it can be removed that way. So it gets stuck to the sediment in the filter media and the clean water flows past. Now this is important when we think about life cycle, or lifespan, I should say, of bioretention systems, in that, theoretically at least, there are a finite number of sites within a bioretention system that dissolved phosphorus can become attached to, right? So eventually, after years and years, you've had heaps of phosphorus coming through the system, and eventually all those particles in the filter media could be used up and there might not be any more left for the phosphorus to attach to, and you might find that you get a drop off in performance of the phosphorus removal of the system, right? And that's fair enough. Now interestingly, that in the laboratory research that's been done to accelerate that and try and predict it, it says that that should happen. Field studies to date, at least that I'm aware of, and of course if you've got if you're aware of research that I'm not, shout it out to me and I'm happy to chat about it. But research that I've seen out of the fields is yet to show us getting to the point where phosphorus is no longer being removed, or that the particulate phosphorus is no longer being removed. But you should be aware that theoretically there's a point where the filter media will be exhausted and you might not be removing any more particulate phosphorus. Now there could be a few reasons why the field studies aren't showing that up yet, and it's possible that there are some mechanisms to kind of rejuvenate that phosphorus removal capacity and so on, but just be aware of it, right? And we might talk about that more in the future. But more importantly that be aware that when we are talking about end of life for phosphorus removal, there's two types there. And there should be no theoretical limit to removal of particulate phosphorus because it's attached to sediment. So as long as the system is still draining freely through the media and the sediment can still be trapped by the filter media, then the particulate phosphorus should still be being trapped with it. It's only the dissolved phosphorus that we have an issue with end of life and the system running out of the ability to remove it. So cool, that's a quick intro to phosphorus removal in bioretention systems. There's two types, there's particulate, there's dissolved. Particulate gets stripped out when the sediment that it's attached to runs into the filter media, and the dissolved stuff, I hope I got this the right way around. So the particulate stuff, I've been paranoid this whole episode that I will have accidentally been getting the terms mixed up here. So let's just clarify this absolutely for once and for all right now. The particulate phosphorus is attached to sediment in the stormwater, and when that sediment flows through the filter media, it physically gets stripped out when the sediment hits the media. The particulate stuff isn't attached to anything in the stormwater. It comes in and it might run into a particle in the filter media and gets stuck to it and gets removed that way. Sweet, that's it for this episode of Ideanthro. Thanks for tuning in. If you want to find out more about what it is that we do, there's a few ways that you can find us. Firstly, there's the website, www.ideanthro.com. You can go there, we got details about all our episodes, all our videos, that sort of thing, right? You can also find our mailing list on the bottom of the front page. You can find us on Facebook, you can like the page, you can send us comments there and messages if you've got stuff you'd like to add to these videos, things you know, if you know something that we've said that you can add to, or if we've said something that's wrong that you can correct, by all means let us know and we can explore that. And finally, so that was facebook.com/Ideanthro if I didn't say that just before. And finally, YouTube. We have a YouTube channel, we post all our videos there, you can subscribe, you can get all the videos straight away. That's it, thanks for tuning in, and until next time, have a great day, see ya.